Alright guys, we'll move ahead with the presentation. Myself and Rick Volker, it's kind of the Rick and Rick show. Myself, I'm from West Mifflin. We've kind of done some multiple robot teams. Rick Volker from Plum, multiple robot teams. So we kind of teamed up on this and talked about some of important aspects of designing a structure, designing a drives, designing a weapon. Besides for weight, it's kind of the most important thing whenever you're looking at a robot. If you don't have a structure that can hold up, it's going to fall apart. If you don't have a drive that can hold up, it's not going to move. If you don't have a weapon that can hold up, you're going to play bumper cars. So those three systems are kind of the most important ones. So we wanted to talk a little bit about that. So what happens whenever you look at a structure? What's the ideation? What do you want to think about with the structure? As you see here, it's necessary to solidify your designs and ideas before ordering any materials. Mike talked about this earlier. And you want to completely concentrate on one type of structural design. So in other words, don't think you're going to have two types. Or you could do this and maybe change this later. Solidify your ideas, solidify what you want to do before you order any materials. So why do you say that? Well, you could say I'm going to make this out of an aluminum frame, where further down the line, you look a little bit more into it, you could have did it out of UHMW, or 70-75 instead of 60-61. In other words, that weight issue, before you order any materials, solidify, do the calculations, do the necessary stuff. There's 16 different types of combat. I call it combots, combat robots. 16 different types of combats to choose from. That's not saying it's going to be a double weapon, a wedge in a drum, or a wedge in a bar spinner. So there's more than 16, but the basics are 16 different types. And a lot of your ideas are going to be cross-referenced between the types. As an example here, you might have someone and you see how many drums are actually up here. Okay, you might have someone looking at a drum where, in all truthfulness, it turns into a horizontal spinner instead of a drum. So a little bit different design. It looks like a drum, but it has different calculations to it. Last but not least in this slide, I kind of make fun of everything. All you have to do is calculate tensile, bonding, torsion, and shearing stress. Then look at your stress of concentration factors of notches and holes. Combine the equivalent stresses of joining, designing parts against yield, rupture, plastic, collapse, fatigue, etc. Sounds easy, right? But in all truthfulness, these are some of the things you want to look at. Okay, all that stuff I just had listed. So this all sounds easy, right? Pretty hard. You got to look at everything. One thing will change another thing. Okay? There's a lot to look at whenever you're looking at materials for your frame. Okay? You can very easily make it out of Lexan. And we've seen some schools come here with a robot made out of Lexan. What happened? It survived one hit. One match done, couldn't fix it. Finished. Okay? So you want to look at materials. You want your robot to be built to take a hit. So the main thing I like to stress is simplicity. Is the key to a frame. Simplicity. You can make all kind of trusses, you can make all kind of this, that. 4 simple bars will give you a square, right? Simplicity. It's just how you configure the bars, how you attach them, and everything else. One thing I introduce everybody, and I kind of put this up, I'm going to stand here first. Anybody ever heard of Rio Box? What is it? Rio Box? No one heard of it. I'm going to put this here. Guys, I do this. This is kind of like my secret information. And I know that Plum has this from Alex. I'm letting a lot of secrets out today for you guys. And I say this for a reason. Whenever I go online and there's some forms I'll show you, I take pride in like Southwestern PA in the BotsIQ program here. We've got one of the better ones. Plum has won nationals over and over and over again. Well, you've got schools from Texas. You've got schools from Eastern PA. You've got schools from Florida, which is our arch enemies. They know this information, and instead of us having 1 or 2 good teams, I like to grow where some of you read some of the information, the background information I'm going to show you here, get this information, and actually build some of the most competitive bots out there. This is what I call a Bible of robot building. It's 367 pages of design information. So it's just like a binder, and it covers every robot type, every material type, every drive type, everything there is for robots, battle bots. It's a free download. Website's up at Realbots. .com and BRs. Anybody know where BR is from?
Brazil.
Brazil. It's a Brazilian team. And yeah, Taurus, Toro. They built some of the world champions, I call them, some of the world champion bots. They put this together 4 years ago, and they kind of did some revisions to it. 4 years ago, it kind of talked more about drums, not about a lot of the other things. But right now, in its state, you can see it's the second version they have up there now. It's the Bible. Anytime I want to know information or I don't know it, I go here. If I'm looking at a material, of course, everybody's not going to know polymer strengths and bonding issues and stuff like that. I go to this. Same thing with weapons. Maybe I've never done a ring spinner before, which we haven't, but we're doing. And this is where I go. So it's the best thing I've found. So I kind of let that secret out of the bag, and you guys will see what I mean by secret, because it's need-to-know information. And it makes it easy on you as an instructor. Designing phase. Some of these things we talked about already. Basically, whenever you're designing your structure, first of all, design on a final robot type. Finalize the design. Finalize it, finalize it. Okay? Finalize your ideas for your drive system. Finalize your ideas for your weapon system. Finalize your ideas for your armor. The ideas for your joining elements. And last but not least is know your material property. Why do we put all this before we even start getting into structure? Because everything affects another. Okay? Everything affects another. You know, one thing I didn't list here, but we're going to talk about a little bit, is batteries. You know, you could actually have an idea for a frame, and we did this our first year. We had an idea for a frame, and the frame's all done and everything else. Well, we switched battery types. And whenever we switched battery types, what it did was throw a wrench in the whole system. It was too high, by about a quarter inch. So everything that you need to know, you know, your drive systems, what motors, because the gearing is going to lengthen your motor. Same thing with a weapon motor. What's the diameter or length? Everything you do, you have to know up front before you finalize your design. If you don't know it, you're going to waste weight, you're going to waste time, you're going to waste material, because you're going to have to do it over again. So get these ideas up front, finalize some of those ideas. They might not be necessarily completely finalized, but you're going to be close. You can draw square boxes and say it's 1 by 2.5 at this point. Now, Mike also talked about this. You know, your first phase of designing is keep it simple. Okay? Keep it simple. Start with chicken scratch drawings. Start with the stuff that every kid is going to write some chicken scratch on. I mean, all my kids write chicken scratch. Okay? Someone said a napkin. You know, I've had them turned in on napkins before from lunch. Any idea is great. Draw stuff down. The other thing you see here is complete an advantage-disadvantage chart. Have the kids look at all 16 different types of robots. Maybe they want to do a drum. Maybe they want to do a bar. Maybe they want to do a ring spinner, a wedge. What's the advantages and disadvantages to each type that you're looking at building? Because every robot has an advantage and a disadvantage. There's no perfect robot. So have them do a chart. You're looking at this robot. What web page did you find it on? Where is it at? What's the team? What's some of the advantages, pros and cons? Next thing, mock to mock robot to robot battles. Now, everybody says, well, how do you do that? You're going to see on the next page, I've got pictures of different robots. And with these pictures of different robots, and these are from way back in BattleBots, the ones that are out there now, just a picture of that robot. We print them on the paper. And everybody's familiar with the old Yo-Yo cards, right? Where you had to throw them down and they fight each other or something. That's what I made this game out of. The kids actually had to fight each other depending on what card they pulled. So they had a class period to look at the background information for that robot, find its pros and cons, and weaknesses, strengths, throw their card down, who won. And this is where they learn which robot type's better than the other robot type. So it's kind of a game with them. They get into it and they start arguing. And I'm kind of a referee that says, you know, this one will win over this. But everybody thinks they'll win. But the other thing is look at the majority, and I'll point out again, look at the majority of robots you are fighting. What do you see up here? Beaters and drums. All right? Beaters and drums. Most robots in BotsIQ PA, I don't know what the exact percentage is, but there's a lot of beaters and drums in there. Okay? There's a lot of wedges in there. So look at the majority that you're going to fight. How are you going to do better against which robot? That might dictate the type of robot you want to build. What's good against the drum? What's good against the wedge? Lifters, we might have saw 1 or 2 per year. Ring spinners, 2 or 3 per year, something like that. So what's the majority of the robots we're going to fight here in BotsIQ? But don't only look here. Because like I said, I kind of let my cat out of the bag with the Rio Box tutorial. I think all of us here, sooner or later, will be on that national level to where, you know, I'm sure that Plum does the same thing as us. We don't really design for local anymore. We design for other competitions such as the NERC and the nationals and stuff like that. So we kind of went from trying to figure out how to beat Plum in the EWCTC to trying to figure out how to beat the Florida team, because they talk the most stuff online. So our kids are kind of hate.
It's because they're all from up here.
Yeah. And the other thing, look at the record of similar type robots. Once you say we're going to do a undercutter, what's the record of the other undercutters that were made? Okay, we're going to do a drum. Well, what's the record of the drum? We're going to do a ring spinner. What's those records? Do they have a good win-loss record? You know, where are they at? They might be 0 and 10. You don't really want to make the same design unless it's a good design that has better parts. So look deep into other robots that are very similar to that. All right, here's what I mean by the Yoyo cards, and this is kind of a little thing that I give to the kids. What will beat what? And I'm not saying that anything will beat anything. You put a square box up there, and whoever can drop it the best could win. But usually, the different types of robots will beat other different types of robots. They have an advantage against them. So you see some of the arrows going back and forth, and usually, mostly all robots in here have 2 or 3 arrows saying it will either beat 2 or 3 different types. So this is kind of what we use with cutters, grabbers, horizontal spinners, vertical spinners, thwack bots, and things like that. So it's kind of our Yoyo Battle. All right, design phase 2.